G'day solar people. Today I am out in Wannery, north of Perth. I've just arrived on site and I'm doing an off-grid system out here. This one is a Victron system. As we can see, we got the beautiful blue stuff on the board there. So this is a board I've made up in the workshop and built it all, and I've got the cabinet in here. So I generally build it in my workshop and then I bring them to site. That way I'm just spending less time on site and I can commission them in the workshop where I've got good Wi-Fi connection and the time to do it all properly, and then just come to site, put everything on the wall and connect it up. I've already done the solar panels. I was here the other day doing them. So that's the cables coming out there, and they go up onto the roof on this shed. And then in the trailer here, I've got the inverter on a pallet, and I've got a couple of batteries. This is one of those systems where I'm building it so the key components are appropriately sized for their future plans. But at present we're only going to use 2 batteries. Whereas in the future they can have up to 8 in that cabinet there. And we've only got 11 solar panels up on the roof there. I'll take you around and show you them if I can see them from the floor. So there'll be 11 facing east and 11 facing west. And but we just got the 11 facing east for now, and that will be more than adequate. And they intend to, as many people do, probably live out of the shed for a while they're building the house in the future. Beautiful property. Apparently there's a lot of pigs on here because there's a river down there, so it's quite wet. You can see there's a lot of green through there and a lot of pigs. I haven't seen any. Can't really see the solar panels either. I should go up here. Yeah. There's 11 Tindo solar panels up there. So no, there'll be another 11 going on the, this is the east side, there'll be another 11 going on the other side eventually. And he's built that little outhouse sort of thing for the off-grid system, and next to it will be the generator, which we're not having a generator yet because I don't care if the power goes off if they flatten the batteries at night, which is highly unlikely because they're only really going to be running a fridge and a few lights while they've got their temporary accommodation up here. But that's really well done, that's perfect. I've seen some where they're freestanding like that as well, so away from the house, just a little shed with a lean-to on the side where the generator can go. That's perfect. So nice stuff there. So it's about mid-morning. Hopefully I can get this system installed and finished today, but if not, I'll spend the night in the van. It's all good. Got my hoist here, which does all the heavy lifting for me, and that'll lift these pallets off and also help me get the system up on the wall. Righto, I'll do another quick video once she's all up and running. Okay, so I've got everything mounted on the wall now in the little room that we've got here set out for the off-grid system. That's it there. Got my solar cables coming down from the roof going into my cabinet, then all the wiring is neatly concealed behind in my cabinet there. This door just swings open, it's just held on by 2 tech bolts there, and then it opens. So a bit of tidying up to do once I'm finished. That's our Servo GX device for communications. I'll connect a modem to that so we can view the plant remotely. That's a spare solar cable going up to the roof for the future array that I mentioned. And this is just on butt hinges that just lift on and off. As you can see there, makes it pretty easy. But now what I've got to do is lift the inverter up onto its bracket there, which is a struggle by myself. That thing is heavy. It would have to be, I don't know, at least 30 kilos, maybe more. But I'll walk it up the ladder there, sort of on my stomach sort of thing. I'll carry it over here, I'll sit it on there, I'll step up the ladder and sort of slide it up my stomach and then slide it down onto there. The only hard part is I've got to get these cables in their slot, so that's going to be a bit tricky. You can see one of my glands have popped out already when I lifted it off, so I'll have to sort that out as well. Righto, so there we go. So once that's on, then I can bring my battery cabinet in, which is going to go there. Put batteries in, wire all that up, commission it, and then do all my labelling, and that should be us done. Righto. Righto, so I've got the inverter on the cabinet now. That was a struggle, that's freaking heavy. But it's up there, it's all connected up. I've put my cabinet in place, and I just wanted to show you the cabinet a bit closer up. So the sides, the back and the front, they all really easily just come off. This just opens up, it's got two little clips there that you can see. Push them in and their side just pops off. And the front door is a glass door with these cool little pins that you just push down to remove the door. That probably means absolutely nothing to an end user, but from an installer point of view, it makes it really easy to work on. I can get in here, I can get my hands in there and work on the two bus bars. I'm going to bring my conduit entries in the side here. I'll have the two positive and negatives going straight into the bottom of my isolator enclosure, and then I'll have my earth and my comms cable going into the bottom of my cabinet up here. Some of the cabinets you get, they're fully enclosed, and that makes this sort of thing like really difficult. But the PowerPlus cabinets have nailed it. They're really good. Ouch. Fuck, that hurt. There's the bus bars at the back. I'm going to install a shunt in the back there as well, which will give us an accurate measurement of the batteries, their state of charge and their discharge and charging rate. And these are our cables that just plug straight onto the batteries once we slot them in, which I'll show you in a little bit once I get that sorted out. Righto, cheers. Righto, so it's 8 o'clock at night and I'm finally done. It's well and truly dark. I've got the van packed up, ready to go. Not even sure if you can see it there. I'll sort of do a quick video before I head home. So this is the finished product. We've got our charge controller there, or MPPT. And obviously it's dark, so there's no PV input power. DC isolator, battery cables, cables going off to the battery to charge the battery. Switchboard. And what I do on all of mine is I have this transfer switch so that if the system falls in a heap, you can flick over to the generator. There is no generator installed just yet, but there will be in the future. They've just got to connect it into this circuit breaker there, and then everything's fine. So this is a 3-position transfer switch. In the center is off, and all the way down is generator. So if the system fell in a heap, what they would do is just flick it straight down to generator and then just manually start the generator. So at least they've got power, and they'd probably give me a call, and until I can get up here, they've got my number there. It's a good thing to have with off-grid systems because you know, we are dealing with electronics and that sort of thing, and if the power goes out, you do want to have a backup. So it's nice just to be able to flick over to the generator, which also gives me a bit of breathing space, so they're not without power completely. They can get by until I can get up here, which removes a bit of the urgency and keeps them with the lights on, which is always a good thing. So that's the switchboard there. The generator will be installed at a later date. It's got a double 15 amp power point below here. We've got our Victron screen, which shows you everything that's going on with the system. Obviously it's not doing much right now. It's got 20 watts, which is probably this floodlight. And we have got a modem here. So this is a 4G modem. This connects to the servo device, which is behind this panel inside the cabinet, and that's the connectivity and basically the brains for the system. So that enables the system to be able to be viewed on the Victron portal, and also enables me to make configuration changes or to check on the system if I need to remotely, which is a big plus with Victron. Because obviously being off grid, if there is an issue with the system, at least I can log into it and have a look at what's going on and hopefully rectify any issues remotely, or at least give instructions. So this is our inverter. This is a Quattro. I didn't need a Quattro here, but it was the only stock I could get at the time. A Multiplus would have been fine. The difference is with the Quattro, it's got 2 AC inputs, and obviously we don't need that. We've only got the generator going into it to act as a charger as well if need be, and to support the loads. So that's our Quattro, 10,000 kilowatt kVA. It's a big one, so that should satisfy all their needs. This is our battery DC isolator. We have some pretty full-on regulations in Australia, so look at the size of that thing. It's almost as big as the inverter. It's ridiculous. So we could have, and back in the day we did used to have what we call the rat trap HRC fuses, which are the cartridge fuses, and we could use them. But now we have this IP23 rating that we have to comply with, which means it must be weatherproof, and it also means that none of the terminals can be touched. And unfortunately the old rat trap type of isolating device doesn't cut it anymore. So we've got to deal with things like that. This is a 400 amp DC isolator. Obviously it's not going to deal with 400 amps at the moment. There's only 2 batteries in there, but I have to build the system to its potential capacity. So 8 batteries can go in there, so there's no point filling it up with 8 batteries and then having to swap over the DC isolator as well. That would just be an absolute pain in the ass. So everything up there is built for its future capacity. All my client needs to do is add another string of solar. So we've only got the 1 string going into the MPPT, or the charge control at the moment, and also add another 6 batteries, and then they're at capacity. So it's pretty much future proofed. They can add their generator to it. So that's that. Let's lock that back up. Right, so that's locked up. It's a good thing that it's in a cabinet. You don't want a kid coming in and swinging off that circuit breaker anyway and flicking it off. That wouldn't be good for anything. And there's our battery cabinet. So we've just got the 2 PowerPlus batteries in there at the moment, Eco 4 4840Ps, and that's only 8 kilowatt hours of storage, which is plenty for now. That's yeah, it's going to be plenty. They're going to have a fridge and a few lights at best. What you will notice is all the bullshit labelling. So we are extremely heavily regulated in Australia with labelling and requirements for the installation of the systems, which is a good thing. to upkeep the standards of the installation, but it's also a bad thing because if you look at all that labeling on there, I mean, really, what are you going to read? I mean, even if you did read all of it, you'd just be fucking confused anyway. The only one that makes sense is my shutdown procedure. So really that should be the only one that's on there, because that's all you need to know. How to shut it down, how to start it up, and my phone number if there's an issue. But no, we have to have all these other labels, which if you read them, would just confuse the hell out of you anyway. So that's the site plan, that one. That shows you where you are, where the battery is, where the inverter is, where the disconnect point. It's just bullshit. It's, yeah, frustrating. And in here we've got the material safety data sheet, which is a good thing because if there is a fire with the battery or there's an issue, at least fireys have got all the information they need there to deal with it. That's also the relevance of this number here. So that's the international, the United Nations number for the type of battery that's installed, so that any emergency services know what they're dealing with. So aside from the labelling, it's nice and neat. I've got the modem on there for the connectivity, and we've got our screen here, which is really cool. And the system can also be viewed remotely. Another thing we have to comply with over here is we have to take a whole heap of photos. We have to get the serial numbers off everything. We even have to take selfies to prove that we're on site, and then it was us that did it. And the reason for that is that in Australia we have a subsidy on the solar panels. It's slowly reducing by 1/11 or 10% each year, I think, something like that. It's got about 8 years left to run, but the subsidy is quite significant. So on a standard, not this system, but on a standard sort of residential system, you're looking at about $2,800 subsidy. So it's pretty significant. But we have that app that we have to take selfies and prove that the registered installer, the trained person in charge, is on site, because some people were getting untrained people and unqualified people just to go out and smash out installations, and then the qualified person would just sign off on the paperwork, which is a statement that they were there, which they actually weren't there. They weren't on site, and it is a requirement that you're on site. Someone recently went to court. It was a Perth WA installer, which is where I'm from, and he avoided a jail sentence for defrauding the subsidy on the solar panels, making false statements, which is declaring that he was on site when he wasn't, and having non-qualified installers installing the system, and then he'd just sign off on the paperwork. So he avoided the jail sentence, but he did get a whole heap of community service and a pretty significant fine, and he had to pay back all of the subsidies that he claimed. So it's worthwhile having an accredited installer to do your solar, and someone that knows what they're doing. They've done the training and got all the accreditation. Alright, hope you enjoyed that. Time to go home. I'll catch you later. See ya.